Chapter 9, Section 1. Chapter 9 is on rational functions. The word rational really means, I think that is fractional. It's going to be a bunch of fractions with our functions. So some people hate it because they hate fractions, but for the most part it's fairly straightforward. I want to start with what is the most common mistake in this chapter. The most common mistake is thinking I can cancel these 6's and get x plus 1 over 1, which is really just x plus 1. And that is not true. You are not allowed to do that. I want to try and explain why. If that was true, if x plus 6 over 6 was actually the same as x plus 1, that would have to be true for any value of x. But if x was something like 3 plus 6 over 6 is not the same as 3 plus 1, because 3 plus 6 over 6 is really 9 over 6, which is really 3 over 2, which is very clearly not 4. So one reason you can't do it is just because mathematically you're not allowed to do it. When you can cancel is if you're canceling whole entire factors at a time. So I can't just cancel pieces of things. If there's addition or subtraction next to something, I can't just cancel that little piece. So here I can't cancel the 2x and the 6, and I can't cancel the 6 and the 6, but the top can factor. And suddenly I have a 2 and a 6, and those can cancel. That becomes x plus 3 over 3. That's how that can reduce, if you cancel whole entire factors. This was a whole entire factor that could cancel on top and on bottom, because nothing was being added or subtracted to that 2, just something was being multiplied to it. That's really the key mistake that happens over and over, is when you can and can't cancel things. Most of this first section, simplifying rational expressions, is really just about how to cancel and how to factor. I'm going to talk a lot about comparing to a simpler problem. If you see a problem, and this will be more and more important as the chapter goes on, if you see a problem and you're like, I don't know how to do this, like if you see this and you're like, oh gosh, well, one thing you can do would be to go back a step, this, and think, okay, I can't handle this right now, but what if I had like something a little bit simpler? Just a couple things on top of each other, 3x over 12x squared. Well, the 3 and the 12 would cancel to become a 1 and a 4, and the x over x squared becomes 1 over 4x, so your answer is 1 over 4x. Basically all you did was find things that they had in common factors, and cancel the common factors. Well, the factoring doesn't go away, and I talked about that when we did factoring in chapter 5. You'll always be factoring in this class at some level. I want to find two numbers that multiply to negative 16 and add up to negative 6. Two numbers that multiply to negative 16 and add up to negative 6 are negative 8 and positive 2. On the bottom, two things that multiply to positive 8 and add to negative 9. Numbers that multiply to positive 8 and add to negative 9 are negative 8 and negative 1. Now these right here cancel. They're the same. X minus 8 over x minus 8 is just 1. So this ends up being x plus 2 over x minus 1. Now if you remember from previous chapter, we talked just a little bit about how the bottom can't equal 0. Which means that my x value here cannot be 1. So if x is 1, 1 minus 1 is 0, and I can't divide by 0. For the record, x can be negative 2. You're allowed to have a negative 2 on top, or have a 0 on top. If the top becomes 0, that's okay. It's the bottom that matters. So there's my solution. It simplifies to x plus 2 over x minus 1, and I have to note that x can't be 1. I'm using lots of examples for this video. I'm going to cancel whatever I can cancel. So for example, 10 divided by 5 is really 2 over 1. 3x's here cancel with 1x here, so I only have 2x's. 2y's on top cancel with 2y's on the bottom, so I have 3y's left on the bottom. 3a's on top cancel with 1a on the bottom, so that's gone entirely, and this y was also gone, excuse me. And the b's cancel off entirely. So I cross out everything that can cancel, either top to bottom or diagonal, never side to side. It's got to be something on top, something that was on the bottom. So I have 6x squared times 2a squared over 5y to the third. So this is really 12a squared x squared over 5y to the third. So y cannot be 0 because 0 to the third is 0. You can't have 0 on the bottom of a fraction. Just simplify whatever you can simplify. If you wanted to start by multiplying across the top and getting 60, a to the third, b, x to the third, y to the second, you sure could, but I think that's a real pain. You have to do that to the bottom also. It's much easier to just simplify diagonally or up and down as often and as early as you can. Okay, division. Hopefully you remember that division of a fraction is really multiplication by the reciprocal. I forgot that was there. I'll probably ignore that one. We'll see. Division by a fraction is just multiplying by the reciprocal. So I have one over here too. No, good. Last time, division of a fraction is multiplying by the reciprocal. So I'm going to take the second fraction and flip it over. Yeah. The second fraction, flip it over. Times x minus 8 over x squared plus 5x plus 6. Let's do a little 2 here. Now that I'm multiplying, I can cancel. I don't want to cancel things while I'm dividing. Right now, nothing can cancel. Don't try and cancel these 16s, or this 6x and this 64, or this 8 and this 6. Nothing can cancel because nothing is in a factored form. Everything has to be in a factored form. So instead, I factor everything. On top I have x minus 8, x plus 2. On bottom I have x minus 8 squared. Over here I still had an x minus 8. So on the bottom I have x plus 3, x plus 2. Now I can cancel whole entire factors. I have to change the directions when I do this. So for example, these cancel and I go sideways. These cancel and I go up to the right. These cancel and I go down to the right. So that way I can see what canceled with what. And I'm left with just a 1 on top and an x plus 3 on the bottom. So I know that x cannot be negative 3. That basically means negative 3 isn't in the domain of this problem. I'll do this one because we're probably getting poorer and poorer at our factoring. I'm not going to go through a review of how to factor. I'm going to pull up the old Chapter 5 videos on factoring. Chapter 5 had factoring. That might not be on Schoology right now, so I'll have to update that. But I mean, guess and check a lot. Oh, I just pull a 4 out of this. On the bottom, I just pull a 4 out. Here I'm going to pull a 2 out of everything to start. That'll probably factor further. On the bottom, I'll guess and check. So right now I'm just kind of preliminarily starting this. Well, if I make this a +1 and this a -1, I've got it. And this one's already factored. And on this, x squared minus 14x plus 45, that's x minus 9 and x minus 5. So I have 2 times x minus 9 times x minus 5. That goes in place of this stuff up here. I'm going to change this. And right now you might be kind of freaking out because you're like, gosh, I can't factor this stuff. You're going to have to just figure it out. Okay, just get on top of it. It might take some work on your part, it might take some practice, but factoring is something that just doesn't go away. I've already taught it to you. If you still need help, go get your help. Does that factor the way that I want it to? Is everything okay there? Okay, can anything really cancel here? 2 and 4 cancel. It's become 1 and 2, that becomes a 2 and that becomes a 1. Nothing else cancels. It looks like all kinds of things should cancel, but nothing else actually cancels here. So I end up with 2x minus 1, x plus 1, x minus 9, x minus 5, over 2, x plus 5, 2x plus 1, x minus 1. X cannot be negative 5, negative 1/2, or 1. Those are all the things that would make these things equal 0, and that's no good. Okay, just a little bit more. And this is basically the same problem twice. If you look at these first two, I just switched to 25 minus x squared. So I want to show what a difference that makes. I'm going to factor the top, x plus 5 times x plus 5. You have to be aware of difference of squares on the bottom. Since x squared and 25 are both perfect squares, this factors into this. And now, those cancel. So I get x plus 5 over x minus 5, which means that x cannot be 5. Over here, this is still x plus 5 times x plus 5 on top. I can write it that way if I want to save some work. On the bottom, it's now 5 minus x, 5 plus x. And in this case, x plus 5 and 5 plus x are the same thing. So one of these on top cancels with one of these on the bottom, and I get x plus 5 over 5 minus x. Don't know why I switched colors there, but I did. X cannot be 5. But something kind of cool happens here, and it's something that you need to become aware of. Does it happen here? Nope, I'm sorry, it happens in the next one. We're going to leave this one alone. If you ever have a scenario where it's like a minus b over b minus a, basically if the a and b just switch spots but there's a minus in between them, it doesn't happen with a plus, it happens with a minus. If it switches spots and there's a minus in between them, this actually just simplifies to -1. I'll show why that is. If I take the b minus a and I switch it, I get -a plus b. Well, then I just switch the order these things came in. Then I can flip around the stuff on the bottom. I'm sorry, I can factor a -1 out of the bottom, and that becomes a minus b. And the a minus b's cancel, and I get 1 over -1, which is just -1. It's a very important thing to see, this relationship. If you have a minus b over b minus a, it just equals -1. Because that would hold true if I had something like 3 minus x over x minus 3, that's just -1. Or 37 minus 12 over 12 minus 37, if you would actually calculate that, you would get a -1. Last thing, this division is basically this. And we know that flips. You can always just take the bottom half, flip it over, and multiply. Now this right now is 2 fractions inside of a fraction. There's 3 fractions with fractions incepted inside of fractions. And there's just all these layers of fractions. It seems kind of terrifying. Right. If you break it down to its pieces, then you'll be okay. This can factor. Cancel, cancel, cancel 1, cancel 2. It's x minus 3 over 2. Written that in yellow, no big deal. There's nothing x can't be, so that's done. Thank you.